Okay, we'll look at some problems that are in section 11.2. Like this first problem here, we want to determine which of the figures is a convex polygon. Okay, a convex polygon by definition is a closed figure, by the way, and it does have line segments in it, and it does have no indentations in it. So we can eliminate number 5 because it's not a closed figure. We can eliminate number 2 because it does not have any line segments. And we can eliminate number 3 because it's just a single straight line. It's not a polygon. Polygon has more than just one side. And this one, number 6, we can eliminate because it has indentations in this particular polygon. So the only two that are going to be convex polygons will be number 1 and number 6. Okay, and these are the choices that we have to choose from here. So in this case, figure 1 and 4 will be considered to be a convex polygon. Alright, problem number 2. Here we want to determine whether the figure is either convex or concave. And here's the figure that we're looking at. Okay, in a concave figure, you can see that there are indentations here. Right here and here, those are indentations. So that means that this figure is going to be considered to be concave. Alright, let's look at the next problem here. Here we're going to classify triangle Z as acute, obtuse, or right, and as equilateral, isosceles, or scalene. Okay, now let's find triangle Z. Alright, here's triangle Z at the very bottom. Okay, if we look at this triangle, the figure triangle Z is an obtuse triangle, because in this case here, there is one obtuse angle in this particular triangle. So it is an obtuse triangle. And also, we can look at the sides and determine whether it's scalene, isosceles, or equilateral. In this case here, both of these sides right here have a length of 10. So here we have at least 2 sides equivalent of the same length. That means that that triangle is going to be isosceles. So here we have an acute and obtuse and isosceles, which is A. Obtuse because it has a obtuse angle, and both the sides have the same length, so it's, in this case here, isosceles. Obtuse and isosceles. Alright, number 4 is to determine the number of diagonals in a regular 49gon, which means it has 49 sides in this case here, and there is a formula for finding the number of diagonals. That's equal to n times n minus 3 divided by 2. And n is the number of sides of that particular polygon. And here we have a 49gon, so that means that n is 49, so it'll be 49 times 49 minus 3 divided by 2. And in this case, if we do 49 minus 3, it'll be 46, so it'll be 49 times 46 divided by 2. And we can do this on the calculator by calculating 49 times 46 divided by 2, which would give us 1127. So in this case here, there are 1127 diagonals in a 49-sided polygon. Okay. Alright, let's look at the next problem, number 5. In this case here, you're told to classify triangle W as equilateral, isosceles, or scalene. Alright, let's find triangle W. Okay, and here's triangle W right here. Okay, now, in this case here, 2 of the sides have a length of 35. As you can see here, here's triangle W that we're looking at. 2 of those sides have a length of 35. they're both the same. So here, with at least two sides equal, that means that this triangle is isosceles. So here, we select B, which is isosceles. And then finally, number 6, classify the polygons shown at the right. And here is that polygon right here. And our choices are either parallelogram but not a square, trapezoid but not kite, rhombus but not a parallelogram, kite but not a trapezoid. Okay, let's look at this. We're told that AD is parallel to BC. Now we only got one side, one pair of sides that are parallel to each other. So in this case here, this four-sided figure is a trapezoid. Okay, so in this case here, it is a trapezoid but not a kite. So we have to select B. Okay, that should be enough to assist you with the homework on the MyMathLab for section 11.2.